let me send something out that says we're starting so that people know and remember, and then we'll get started. Link. Share. Okay. There we go. Good. Announcements should be posted. We should be ready to go. I'll give about a minute for people to kind of filter in, and then we'll start. There we are. Okay. We should be set to go. This shouldn't take all that long, but we do need to get started here, especially since we have a half day next week. I want to get us started. I'm going to be tossing a couple of definitions at you and terms that are going to be really important going forward here. So make sure that you write these down. And if I say a word and you don't immediately know what it means, make sure you write it down and have it ready to go. So, first one is a midpoint. And I alluded to this, I referenced this earlier this week and said between doesn't necessarily mean that it's exactly in the middle, because now we're talking about exactly in the middle. So a midpoint is just a point in the middle. And so in this diagram, it's going to be that point M right there. And we're saying that it bisects the segment, dividing it into two congruent segments. So I want to talk about each of those terms and make sure that we know what they mean. All right, bisects, we're going to talk about this more in the next chapter, but bisects just mean splitting in half. And the reason we'll talk about that is because when we talk about angles, angles can also be bisected. We can split an angle in half as well as a segment in half. In fact, we'll call splitting an angle in half an angle bisector. So it'll be important to know that word as well. And the other word that's in here that you might not know is congruent. Congruent means same measurement. Congruent just means they measure the same. And we use that to talk about all kinds of different geometric shapes or figures. So anything that we can measure, we can compare them and see if they're the same and say that they're congruent. So right now we're talking about segments being congruent. We'll eventually talk about angles that are congruent. Eventually in a chapter we'll talk about entire shapes and how to say that, say an entire triangle or a square is congruent to another square. But it's going to stay the same meaning. The meaning is going to be all the measurements being the same. So that's going to be our definition of congruent. And the symbol that we're going to use is going to be an equal sign with this little swirly over it, the little tilde, if you take Spanish. So that is the symbol for congruent. Those are our three words that you need to know. Midpoint, point exactly in the middle, and that's going to make the segments, splits it in two equal pieces. And what I mean by splitting in half, another word we use for that is bisecting. That's less important for now. But the main one is going to be congruent. Congruent means we have the same measurement. So those are words, make sure that you know them. And so to put all that together, we can say that if we have a midpoint, that the two pieces are congruent. So we're going to say segment A to M is congruent to segment M to B. Because remember, if we have a segment, we put a little bar at the top. So there's A to M and M to B. Those two segments are congruent, and that tells me that they have the same measurement. In the diagram, we mark that with these little tick markings right here. So tick mark there and tick mark there, to tell me that in the diagram, that they measure the same. So sometimes you won't even be told that they're congruent over here in this bit of information, but the diagram will have these little tick markings. And you'll need to know that that means that they're congruent. So in other words, if I tell you that A to M is 5, then you should be able to tell me that M to B is going to be the same, that it's also 5. And of course, the whole thing is going to be 5 and 5 is 10. That's what we talked about earlier this week. So that's the idea of the segment. We're not just splitting the segment up somewhere in between. We're splitting it exactly down the middle, and the two pieces are going to be equal. And so just to give you a little bit of a different visual of that. This is going to move around in a second, but here's A, here's B, here's the midpoint M, and so here's the segment. And you'll notice these are congruent. And I'm going to move these around so you can see how the point changes when the midpoint, how the midpoint changes when the point changes. So this point right here is staying the midpoint. It's staying exactly halfway in between my blue and green point, where it's more of a purplish. So that's split exactly into the middle, so it puts it into two equal pieces. So that's a useful bit of information for us because a lot of times we want to know if two measurements are the same. And so knowing that something is a midpoint is going to help us do that. So let's look at some examples. I'm going to do 2 examples today, and that's going to be it. M is the midpoint of the segment. Draw and label a diagram, and then find the length. So what we're going to do is we're going to draw our diagram. M is the midpoint. We have A and B on the ends. Here's A. Here's B. And we're still going to put M in between it, but now we're going to put M exactly in the middle. And then we can label the pieces that we have. A to M and M to B. A to M is 2x plus 35. So that's our distance from A to M. M to B is 5x minus 22. So that's this piece here from M out to B. And what we know is that because M is the midpoint, those 2 pieces have to be the same. And so we have this 2x plus 35 and this 5x minus 22. We know that those 2 have to be the same. So we're going to set them equal to each other. In other words, here's the marking we can make in the diagram. Or we can say segment AM is congruent to segment MB. Remember I said your equations should always be grounded in the geometry in the diagram. If you're setting these 2 things equal to each other, you should be able to point in the diagram and tell me, here's how I know these 2 are the same. Let's solve the equation. Let's move these to the other side. So we're going to subtract 2x. Get everything with x on the same side. So I got 5x minus 2x is 3x minus 22. Now I'm going to add to both sides. I'm going quick because if you need to pause and go back, you can pause and go back. And then I want to divide to get rid of the multiplication. Divide by 3 on both sides. So that means we're going to have x equals 19. So 19 is our answer for x. Then, to find A to B, again, if you're not ready for that yet, you can pause and go back. To find A to B, what we want to do is remember last time we double checked our answers to make sure they were working out the way we thought they would. So we're going to use that to figure out what A to B has to be. So we know that A to M. These 2 should be the same if we did it right, because the pieces should be equal. 5 times 19 minus 22 equals, that's 95 minus 22 is 73. Sorry. I'll edit this out because I did it wrong. A to M. A to M is the 2x plus 35, so it should be 2 times x is 19 plus 35. 2 times 19 is 38, and 35 is going to be 73. And then M to B should work out to be the same, hopefully. That is 5 times x is 19 minus 22. That's 95 minus 22 is 73. So that's how we know we have the right answer, because these 2 work out to be the same. Now, We know this is 73, and this is 73. And so then we can go on to say that means that A to B has got to be 73 and 73, the entire distance from A to B has got to be the two pieces put together. That's what we talked about all this week. So that's going to be 146. Apologies for earlier. I just mixed up which one was A to M and which one was M to B. Number 3, I'm going to have you do on your own, just as a heads up. So we're going to do one more together, and then I'll be asking you to do number 3 on your own. So try and work ahead of me on this one if you can. Remember, we have A and B, and we have M as our midpoint, which means that these two pieces have to be the same. Now let's label the diagram. This one's going to be a little bit different, so be careful. A to M is x minus 52. Here's A to M. And this time, we have A to B as 3x plus 6. So this doesn't go over here in this piece like it did on the last problem. This time, A to B is the entire length, 3x plus 6. That's the entire length from A to B. And so we need to figure out what equation to set up to get there. How does A to M and A to B have to do with each other? Because they're not the same. A to B is obviously quite a bit longer. So don't set them equal to each other, because if you look at the diagram, they're obviously not equal. But I do know that the pieces are equal. A to M and M to B. Remember, I told you if this was 5, this had to be 5. They have to be exactly the same. They've got to match. So we'll just match them. X minus 52, well, this one's got to be x minus 52. They have to match. So we'll make a match. And now I've got an equation. Because what I do know about A to B is it's got to be the sum of the parts. It's got to be the pieces of the segment added together. So I'm going to add together the parts and get the whole thing. 3x plus 6 is the whole thing. Uh-oh. We move this stuff down here so that we can see. Not easily. That's annoying. Just moving it down so you can see better. Because I am in the wrong corner for this. Oh my god. No. This is the one I want. That's better. Okay, backing up a second now that you can see. Here's my pieces. I know this is x minus 52 because they have to match. They have to be the same. So that's how we get these two pieces. And then the whole thing is 3x plus 6, so it goes at the end. So I've got an x minus 52 here. And I've got an x minus 52 here. And they have to add together to be the 3x plus 6. And now we solve. Again, I'm going to go quickly. If you need to see something again, then pause it. X on an X is 2x. Minus 52 and minus 52 is going to get more negative. So it's going to be minus 104 equals 3x plus 6. So then we're going to move things around now. Only put things together if they're on the same side. Now that they're on different sides, we need to move things around to the other side. Still have the negative attached to the 104. Watch out for that. Then I subtract 6. And we can get x equals negative 110. I might use a different example when I go to post this because I don't like this answer. So I might re-record this with a different example. But the idea is the same. The pieces have to match. They have to be the same. Then we can plug in and find m to b. M to b, which we know already is the x minus 52. Okay. That's all I have. Number 3, you need to do on your own. And so that's all I have for you for now. I'll post this more. This should be up for you later. And that's all the notes that you need. So those of you in my first hour class should have a link to a Zoom meeting, and I'll see you there at 12:30. Everyone else, I hope you have a nice weekend.